Alright, trying to make an improvement on my design of the stem unit and the actual branch unit. The branch unit, I emptied out the junction box here earlier this morning and removed everything that was in it. So it's going to be upgraded to prototype version 1.6. I'm going to be adding a breadboard, less sensor adapters, and I got the parts in to fabricate my own connectors. So I'm doing that now. Not too bad, even with my mistakes, but got a new tool in. Also returned, oh, there it is, yep. Returned the motorized ball valve that I was using before. Got another manufacturer, cost a little bit more, but I also got it in same day. So I ordered it like 4 a.m. this morning, and got it to the house like 12 hours later. So that was crazy, using Amazon Prime same day shipping. So that's like a same day arrival. I'm still amazed by that. Also, even the return I'm amazed by, because with the return I used the Amazon locker. So printed out the label and everything, put it in the Amazon locker, and then that was my return. That's at a 24-hour 7-Eleven. So that was pretty cool. I'm going to be adding a connector to this. I'm not sure if I'm going to use some of the newer connectors that I'm getting tomorrow, which are bigger, but I might just be using the pin connectors like I'm working on right now, to actually get that done. Also want to probably fabricate more connectors, and then of course I'm going to shrink wrap this one, and then probably even cut the end off of this one. Not sure, we'll see. It might be just better just to leave it as is. I'm kind of on the fence about that, so we'll see. Same thing with this one. I'll be adding connectors to it here in a little bit, and then getting this thing hooked up to my stem box. This motorized valve is a 2-wire auto return. So once energized, and I'll show you that in another video, or maybe even this same video, I'll just splice it together. But this is a 2-wire auto return, so it turns and opens once energized. Oh crap. Once energized, it turns and opens, and then once de-energized, even if it's like partially open, it will return to close. So that's pretty cool to see that. In fact, let's see if I could show it to you. Oh, okay. So I can get this in the shot here. No, probably not. Stay right there. And my tools here. Okay. What I'm doing is just connecting the wire to green is the ground. In this case, the red is the positive, and the green in this case is the ground. Some places that is standard. Almost done. We'll be with you in a second. I understand, horrible production value, but whatever. I fix computers, not make videos. Anyways. Boom, there we go. Alright, so I got this sucker connected. You can buy these AC/DC power adapters here. Oh shoot, there you go. AC/DC power adapters here. This is a 24 volt half amp. Alright, so what I'll do here, take this. And I will plug it in. And once you plug it in, as you can see here, it opens up, and I can see the inside of my bucket there, right? And then I unplug it, and it automatically returns to close. Plug it in, Takes about 5 seconds to actuate. So with that, all I have to do is hook it up to my relay, and then write the code to switch power on, or connect the normally open side of the relay and close it, and then open it up when I need it, or open it up when I want to turn it off, and it'll return to a closed position. Then I can also add logic to it, or kind of like a fail-safe mechanism or a check mechanism to say, oh, okay, is there water flow through the water flow sensor, which is on the same bucket and right below it. So if there's water flowing through it and this is supposed to be closed, send notification. That'd be pretty much it. Alright guys, as always, thank you. Peace. Alright, so improving my design on these boards, and this will cut costs down a great deal. What I did is use a breadboard, a little small one. It's a little bit more decorative. I kind of don't like how loose these pins are, but it is what it is. We'll see how that works and if I can make it any better by probably flattening out, and so I can widen the actual pins on this. But breadboard, or sorry, from the Raspberry Pi terminals to the adapter, which I think it does a 5 amp or 5 volt pull up or something like that. So gives enough power to, or strengthens the signal, I believe is the proper term. Strengthening the signal coming from the digital sensors. On the Raspberry Pi, there's only one digital sensor. So what I had before is that I had a whole bunch of cables put together like this, and this was like in the branch device version, like 1.5 or some shit like that. Actually, yeah, version 1, and I was gonna end up, probably trying to find a way to mux this all together and solder it or whatever, just so I can get a cleaner. Something just dropped. I'll pick that up later. Just so I can get a better connection, or a cleaner connection, or even a simpler connection to my I/O pin number 4, which is this green one here. Get a little bit closer. So that's I/O 4. So I only have one thing in there. So this cuts down cabling, mess, and everything like that. So I was like, well, how can I do this? And then it popped in my head because I've seen it before. And I just recalled, I was like, somebody put a whole bunch of these sensors on a breadboard and just ran it that way. So what I did here is, on the breadboard, I have everything on its. Let's get this power cable out of the way a little bit here. There we go. On the breadboard, it's a little bit cluttered, so I'm going to space these out a little bit more. It's just everything's kind of close right now because of the way I have these wire spliced. I try to do this as quick as possible so I can prove the point and move on to the next thing. But I have the negative, the positive, and then the actual signal wire for the digital sensor I/O pin number 4, or I/O 4. And then on the same row, I have sensor 1, sensor 2. And as you can see here, sensor 1, sensor 2. So that's pretty cool. I can go into each one of them and cap the device, which I'm going to do here in a little bit, but I'm sure they work. But this is really nice because then I can connect as many sensors as I need to. I think I've seen somebody do like 20 sensors off of a digital sensor port. And then also if I have multiple sensors or different types of sensors. So all I would have to do is just have this breadboard and then jump to another row if I need more devices and go down from there. And then try to keep it as clean as possible. The only problem I have is that it's very loose. So that might suck. We'll see how that works, especially with transport or anything else like that once I start selling these things a little bit more. The actual physical setup, because that's a part of the all of this research and development, is creating a product that I can actually resell and ship out. Again, everybody can do it themselves for free, but not everybody's into that, and they just want the solution and go from there. So right here, I got my relay set, and then I'll have all my fans hooked up to this, and I can kind of design it however the person wants, and then drill whatever holes that need to be, or drill whatever holes necessary. Also, I don't like these push terminals. So I did order quite a few off of eBay the other day. I think I ordered like 5. And they're coming from China, so it's going to take a while. So I might get it like end of this week, next week or something like that. I'll go from there. But yeah, I'm very hype about this. This is really cool. 2 sensors, you know, so it's really cool. Grow back stem, improving it every chance I get, man. All right, thank you guys as always. Peace.